Huh? Everybody left, and they have no interest in fabrication. Anyway, Rick probably introduced who I am. I'm Hong Lim. I've been with Parsons for the last 22 years. This is actually not my expertise, the fabrication. I'm a design engineer, just like Rick, but I do have the opportunity to visit these shops. So this is actually the other side of Worley Parsons. So what we do here is all strictly design engineering, and the fabrication part is I just happen to have an opportunity to visit some of these shops. So I did see how they work, how they fabricate these vessels. So I thought I want to share some of my experience with some of you guys. So anyway, the vessel fabricator. Oh, before we get to this point, I was talking to Juan. We do the design here. We do we went out for bid, and we select the vendor. How do we know we select the right vendor? How do we know?
You're asking me?
Yeah.
Based on the technical evaluation on whether or not they met all the requirements. Obviously, if they were the lowest bidder, and most important, from past experience.
Yeah, the past experience. There you go. Before we went out for bid, we have to know. Okay, I do have a column, very tall column. Okay, diameter based on the diameter, and we work together with the procurement group and see. Okay, who has the most experience? Who do we trust to build this column? Right? So we worked together and decided, okay, let's go to A, B, C, D, E, these 5 vendors, and let them bid on it. So after they bid on it, so we select one vendor. We call it the successful vendor. Then, before we go into, there's another slice, about 2-3 slides down. We do have a kickoff meeting. We call it prefabrication meeting. So that's the time we go in and we sit down with these guys. We sit down with the engineering group, the QA/QC group, production group, and we go over all the specs. And this is something that is not in this slide. Go over all the specs, make sure they understand our spec, make sure they understand the client requirement, and we go over before they start. So now this slide actually is what they're looking at to bid this job. So when they bid the job, first of all they have to know what kind of steel, whether it's a carbon steel, chromoly steel, alloy steel, or clad steel. And that clad, actually in that clad category, we have another category called overlay steel. And actually, those steel are based on that material consideration, whether it's going to be a low temperature requirement, high temperature requirement, or this is going to be a corrosion resistant requirement. Okay, if it's a low temperature, we probably pick the low temperature steel. And the high temperature, we go to chromoly steel, and for corrosion requirement, we go to clad or overlay steel. And then on this side, actually these slides are we took it from a vendor. Those are the basis that they consider. Whether the steel price is fluctuating, and then they compare the cost comparison. And material received is when they receive a material, how do they identify, how do they control it, and then how do they store it. Okay, the next slide. And as you can see, before they bid on a job, they have to go out and actually get their quote. Same thing when we bid on this job, We got a quote from a ABCDE vendor. Same thing, they have to go and source their material. And as you can see, from 1996 to about 2002, 2003, there's a very little cost increase. Because during those times, basically businesses are down. They didn't have much business. And then after 2003, you can see it ramp up quite a bit. From 2003 to 2004, there's a 50% increase. I actually work on a job. We bid on 2004, and by the time we issued a PO, all my cost estimate just went up 50%. In 2005, went up again, and now this chart actually is pulled from last year, I believe, huh?
Yeah. 2005.
So I would say from 2004 to now, probably double, just on the base, material cost alone. And this is a cost comparison that they show you if we have to use 5/16/70, which is a plain carbon steel. And then there's a 1 1/4 chrome, 2 1/4 chrome, 5 chrome clad stainless steel, and also duplex, Inconel, Monel, Hasselblad.
This is the most recent price?
Huh?
This is the most recent?
No, this one also pulled from last year. Right now, probably, I would say, went up 30-40% easy. Next time. And this chart actually shows the material received, identification and control. When they receive all their raw material, all incoming material will be inspected. They have the shop inspection. That's, the inspection actually was done in the mill. And then when they receive it, they want to make sure what they receive it has meet, however they spec it out. And all these material that comes into the shop has their own identification. So the mill actually provide the identification, which called the certified mill test report. When they actually fabricate that raw material, they will have to do all kinds of testing. They have to provide the chemical composition, and they have to provide the mechanical testing. So they do all kinds of tests in the mill already. But when you receive it, you still want to make sure whatever we spec out, they meet our spec. Okay, next one. Now, after they receive the material, they have to mark it. Okay, this plate is for tag number such and such. And all the, let's say they receive a bunch of nozzle flanges, they have to cover it and protect it. And then, before they start rolling and cutting, actually the vessel, they make it like a kit, like a head. You probably see it in the next slide. They take the head, and then they punch a hole, and they actually fabricate individual pieces. Then the final assembly, they put it all together. Okay, the next one. Now, you probably see here, this slide actually shows that this is towards the final assembly. Now, this is a roll machine, a roller. When the plate comes in, it comes in as a flat plate. And this one is it's a hard roll. Hard roll usually, they do the hard roll on a very thick plate, not on a thin plate. Okay, here's another roller. This one's a cold roll machine. And when you do the cold roll, you probably see at the edge, they have to break it a little bit. They have to use a smaller roller to press it so they have a lead. They take the lead into the bigger roll. So they will roll it to a required diameter. Now here's identification that I mentioned earlier. Now here's where they store after they roll it. The rolling machine guy, they keep rolling. After they roll it, they set aside out in the yard. Now they brought it in. This is a heavy wall section. They brought it back to the shop. Now this one is this one just came out of the furnace. You know, earlier they show you the hot roller. They have to take it to the furnace. They heat up to like 1600 degrees Fahrenheit. So that makes it easier to roll it. Now here's the head spinning machine. And the way they do this is they take the plate. And then they slowly, press it. And then they spin it. Now here's another storage area in the backyard. Okay. Remember earlier they said they fabricated in a small little kit. They take the head and they punch a hole and they install a nozzle. Now here's the same thing. They install a nozzle on the head. Okay, these are the components that comes into the shop. These are the nozzle components. These are the long well neck. Again, more component. Now, earlier remember I said some vessels they have to overlay it. Either we go to clad, or even we go to clad. When you order these small components like a small nozzle, they don't come in as clad. So they have to do it in the shop. They take the weld rod and they keep, just like weld it in. Now here is the. Did we skip that? The welding process?
No,
Oh, okay. This is a slide that shows they weld the pieces together, the two shell cores together.
Is that guy with a hammer? I'm sorry. Is that a hammer he has in his hand and he just banging it?
No. Actually, he's holding the torch. Yeah, he's holding the torch. Okay, this one here, in some cases, we have to refractory line, right? And these are the mesh for the refractory line. Now, this is almost complete. Remember, they put all the pieces together, and then the next step, they are putting the insulation anchor. Now this is pretty much a finished product, and they just show you what is the 17 feet diameter by 180 feet long comparison to that human, the man. Go ahead.
Also with the skirt of the vessel.
Say that again?
Do you also work with the vessel skirt? Besides the vessel itself.
Yeah. They attach the skirt later.
I came across a scenario where the vessel is made of carbon steel with a 1/8 corrosion allowance.
Okay.
But then the vessel skirt, I think we define as just plain carbon steel without the corrosion allowance.
That's correct. Basically, the skirt just see the environment. There's no fluid. There is no corrosion in there.
But what about when? I guess my question would be then next is what about for some of those alloys or some of the other types of?
Well, the alloy, we manufacture vessel with the alloy for a reason, right?
Yes.
Either for corrosion or for temperature. But the skirt, why do we have to spend money? You probably saw the cost comparison between the SA36 and the chrome is like 10 times.
But don't you have any problem in terms of differences in metals that you have?
No, usually we can attach the carbon steel to the cold moly steel, but they're using the different weld procedure. We're going to cover that weld procedure. They're using the different, procedure to weld it. Or the other way around was we can use a foot of skirt, same material, attached to the bottom head, and from that foot down, we go to regular cheaper steel, just to save the money.
So for a skirt, can I just make, is there a good assumption that all these skirts will be made of carbon steel?
That's true. In 99% true. Okay. Remember earlier slide, they said all the material should be segregated. This is one area. This can actually is a stainless steel can. Now, that area, somehow they have carbon steel that get onto the stainless steel. It's getting corroded. So it's pitting. Now, welding process. This is, like I said, this is not my expertise, but we do have to get involved. What kind of welding process they're going to use, what kind of weld procedure they use. So basically, most of our vessels are based on these 5. You see, most of our vessels manufactured based on these 5 welding process. The first one is submerged art. Second one, flux core. And flux core and submerged art is almost the same, except flux core they can do automatic. Submerged art they also do automatic, but flux core is faster. And then we have shear metal artwork, which is a stick. They use a stick in a hard to get area, or whenever they fit the nozzle into the pressure boundary, into the shell or head. And the MIG, the gas metal arc welding, in other words, they call it MIG. Then we have the TIG. Go ahead. Now, this is actually a submerged art process. Next one. And now, on the pressure boundary, or yeah, we do from inside and outside both. Yeah, inside what they do is they take a can and they stick a boom inside, right? And then that boom, it travels. It's an automatic machine. Or in other words, if you want to weld the circumferential C, they stick a boom inside and then roll the can. So that's how they weld inside. Okay, this is a slide that they show they're fitting the nozzle into the can. What are you doing here? Same thing. Okay, same thing. They're welding a flange onto the nozzle neck. And this is actually a stick process. Yeah, the next one. This is also a nozzle. We probably have a lot of repeat slide. Now, weld procedure qualification. Okay, anytime they weld a pressure vessel shell or head, They have to go by the procedure. Okay, that procedure is, it has to be qualified. Basically, the PQR, the qualification meaning you take a piece of coupon, okay, a certain thickness. Take a piece of coupon, same material, 5/1670 or stainless steel, okay. Then they weld it like a sample. The sample welded, you have to record it. What kind of heat they put in, what kind of weld rod they put in, what kind of process, either SAW or SMAW, okay. They record those, then they actually take that coupon to the lab, and they do the bend test, they do the shear test, the tension test, all kinds of tests, then they record it before they actually use it, you know, on welding the vessel. Now, weld procedure.
Is that done before every job, or is it
No.
done once, or how's
No.
that?
Every shop, if they want to be in a pressure vessel business, they have to do those, just like, you know, it's like you go to McDonald's.
Or like we do it, they only, they're qualified for a certain amount, and they have to re-qualify again?
I think we're good.
When they do their procedure qualification record, and they send the sample out and it passes, are they qualified for a certain amount of time, and then they have to go back after that? Do they have to?
No. They as long as they keep those records, as long as they use the same material. Correct me if Rick. As long as they use the same material, you know, they're good. I've seen PQR good for what, 10, 20 years? Yeah. And weld procedure. Weld procedure, let's say we have a carbon steel vessel, half-inch thick wall. Okay? They do not go back out and do the weld qualification. They will just use this, whatever they have inside, in-house. Okay, those are already pre-qualified. They have those like a standard. It's like a standard. Like I said, they already, you know, do the PQR, and they write down what kind of heat they produce, and also what kind of weld rod, whether it's a stress relief or non-stress relief. It's like a standard they use. Now, I just said half-inch wall thicknesses, right? I'm going to manufacture this vessel. So can I use a weld procedure that's already qualified for 1 inch? Yes, the answer is yes. Because the weld procedure actually covers a wide range. He probably cover from 3/8 all the way to 1.5 inches. So anything fall in between the thicknesses, they can use this weld procedure. And then the WPQ is a welder performance qualification. All those welders, they actually have to do a practical. They have to do the actual welding, and they also have to pass the test. Now, this is a Sharpie impact test machine. You know, up there's a coupon. That's a coupon. It's a sample piece of plate, and they have to test it for the brittle, and see how this piece, how brittle this steel is. This one. And here's a coupon. And those notches that you see, those are just a small notches to lead, so it will break at that notches area. Now here's another impact machine. And here's the broken pieces after they tested. And this is actually a tensile. After they did a tensile test, they actually put on a machine to pull it and see, you know, how much force they put in before it breaks. Here's a tensile machine. And this is actually a bend test. Now, vessel quality control. In the shop, they have to have a quality control plan. So you buy anything else, okay? You want to have a certain quality. And actually, inspection and test plan come later. Remember I said pre-qualification meeting, pre-fab meeting? That's the time that we went in. We went over all the specs, and procurement guy usually tag along. You have to go over with,
Free lunch.
no, go over with all the commercial issue, and dimension verification that come later, before when the final assembly is done, and that's why they do the dimension verification. And NDE is the one that something that they do along the way. Okay. Number one, the most important one, X-ray. What we do X-ray was to check the well. They actually take the film and they shoot the X-ray. Rick probably went out earlier. You covered earlier that whether it's 100% X-ray or spot X-ray. 100% X-ray, they actually lay all the film behind the plate, and then they shoot the X-ray. And the RT, usually we try to find the flaw, any flaw that inside the well. And then UT is another test, ultrasound test. It's ultrasound machine. They went to the, actually UT cover more. UT cover, we can also check the flaw in the plate and also the flaw in the well. And the UT will pick up horizontal flaw. Sometimes the plate has a crack, small hairline crack horizontally, or they have hairline crack vertically. So UT will pick up both of them. And Mach particle test, that's another test that they try to find the flaw. And MT, mostly it's not as strong as UT. MT only can pick up like a very shallow, like on the surface, near the surface area. And hardness test, you probably saw hardness test actually is when we put the two plates together, we weld it, okay? The nearby vicinity, maybe ½ inch to 3/4 inch next to the weld, and the metal get hot because it already went through the heat. So this area get hot, but the rest of the area may not be as hot, right? So that test, the hardness test, they use the testing ball, and then they drop it and see what kind of ding. They actually test the hardness. And PMI is a positive material identification. And PMI, actually they use the nuclear testing device. And they just have to shoot the ray to the plate, and the reading will tell you, what kind of chemical composition it had, how many % iron, manganese, magnesium. It will break down for you. And the ferrite check, another machine that check the iron content. And the final inspection, this is after they do all these, and they go to the hydro test. Every vessel goes to the hydro test. Okay. There's some option we can use. We can do either another option is to do the air test. But air test is very, very dangerous. It's like a bomb. Hydro test, when the vessel yield, what happens? It just pop. Okay, but the air test, it will explode. So this is a quality control manual that every shop need to have. When you walk into the shop, we did not cover the selection of, we did not cover the pre-qualification section. Earlier I talked about how do we know which shop is good, right?
Right.
So when we walk in the shop, first thing we want to see is, hey, how good is where's your quality control manual? How good is your QAQC program? So that's when they have to have that program in place. Now, this is a QA plan for each individual job. Let's say I want to let this guy build a column. Okay? They have to come up with a plan, how they're going to build it, and how they're going to test it, how they're going to inspect it. That's a plan. And this chart, actually, we call it ITP. That's an inspection and test plan. That's like a roadmap. Okay? Number one, I want to do this.